Good day, my name is Franzua Heever and this is my DPJ2601 Design Project 3 Microcontroller based Automated Streetlight Control System project. Today I will present the project. The presentation will be done in two stages. Stage 1 is the PowerPoint presentation where I will walk through the theory of the project and point out some of the more important parts of the project in terms of the project report. Part 2 is where I will go through this prototype over here, which is the final product from the project. This is the design project prototype, and in part 2 I will explain the functioning of this prototype. So I will go through all of its components, I will explain it from a distance, and then I will explain it in close-up. And after that I will demonstrate the working of the prototype and show its functionality in real time. Thank you. We have firstly a sender module, and over here we have a receiver module. This particular prototype is demonstrating two streetlights. So more streetlights may be added. This prototype is only focusing on two, just to demonstrate the working principle. So this particular one on the left over here is the sender module, and this module is the one containing the day-night switch. So this is where the sensor input will come from, and this is where the decision making starts. This one on the right side, this module is the receiver module. This module will have all of the modules that the sender module has, but it does not include the light dependent resistor or the day-night switch. And this module will take commands from the sender module. So essentially it's a wireless system, and it has up to 320 meters of range via ESP now. So we can take this module 320 meters away and it should still receive the message. So the light bulbs over here, they imitate streetlight bulbs. So these are 6-watt LED bulbs. And the solar panels over here are used for charging the system. So at the moment they are not in use, but during the daytime they can charge the system and ensure that there's enough battery life left during the night time when the system is operational. The system uses a relay to switch each of these lights. So there is a 5-volt 10-amp rated relay inside of each of these modules. And if we were to just start with the sender module over here, so we will do a close-up in a second, but essentially inside of the sender module, what we have is from top to bottom, like I said, there's a solar PV panel responsible for battery charging. Then we have the LED bulb, which is a 6-watt bulb, and it's just imitating a street light lamp. And then this lamp over here is wired at the back of the panel using a cap tire wire, and it comes into this terminal port over here. And then the live connection is the neutral connection is normaled through to the neutral going into the wall socket, and the live connection goes through the relay switching circuit. So the live connection is the one that is broken or connected depending on whether the light needs to be on or off. Then we have the control box over here. This is where the microcontroller system is based, and the relays inside of the box. So I'm only using the terminals outside for demonstration. These terminals would be inside the actual streetlight lamp, and the box would be outside on a real system. So then and then there's a day-night switch down here, which we'll have a look at in a moment. Once this system senses that the absence of light has reached a certain threshold, the day-night switch will activate, and it will tell this microcontroller to close the relay, and the light will go on. And also at the same time, a signal is sent wirelessly via ESP now to the other ESP8266 node MCU microcontroller in the receiver unit. And we can have up to 20 of these receiver units. So in other words, we can have one sender and 20 other street lamps working from this one send day-night switch. So this signal can be relayed then to 20 other street lamps. The concept is that there's one sender module with a day-night switch, let's say at the top of the street, and then we have multiple receiver modules or client modules that will receive the signal from the server module. And this is the exact same system we will have a look at in a moment, also with the same wiring and connection done to it, just without the day-night switch. Now we will have a close-up look of the system, and after that I will demonstrate the system. Thank you. So if we have a look at the sender module or the server, inside of this enclosure we have the following. So I will just start from the bottom. We will start with the sensors. So there is a status indication LED. This LED will be active when the street light should be on. So there are various reasons for this. The first thing is to show that the system is indeed active. So if the street lamp bulb is blown for whatever reason, then this light can still be on, and it will indicate that the system is in fact on, so that the system is working but the bulb may be faulty, or there may be another fault down the line. And then the next sensor input that well, this over here is our sensor. So this is the day-night switch, and it's the LDR sensor right there. There is a reason for placing it underneath the enclosure, and that is that we do not want this street lamp bulb to interfere with the reading, because if that is the case, then we will have a situation where as soon as the light turns on, the day-night switch will sense the presence of the light intensity again, and it will simply just switch the system off. So it will bounce back and forth. So this has been placed here in order to just pick up ambient light, and in that way it can be more accurate. It is not affected by the LED. This was tested, so the LED was just blanked out on the one side to ensure that it does not interfere with the day-night switch. Then if we go inside of the enclosure, we have at the back of this panel we have the two 3000 milliamp hour 3.7 volt lithium ion batteries, and they provide power. Firstly, they go into this battery management system for lithium ion batteries, and they basically provide over here we have an 8 volt output out of this board, and that 8 volt output comes into this board over here. Now this circuit board that has been soldered onto Vero board, on this side is the power supply. So I will just go closer. We have the LM317, that is the on the right side there, that is the adjustable voltage regulator, and that is used to step down to 24 volts from the solar panel to 9 volts, well, approximately 9 volts. I think it's closer to 8 of charging voltage for the batteries. Then this disconnect switch over here, this connects the solar panel. So if for any reason the DC from the solar panel needs to be connected, it's connected at the moment and it's disconnected in that position. Then we have the 5 volt regulator on the left here, and that is the one that powers the microcontroller. And the 5 volt regulator is basically used for the microcontroller first, and then secondly it also powers the relay switching circuit. The transistor over there is the 2N3904 transistor, and that is used to switch the 5 volt relay. That was done since the architecture of the ESP8266 is a 3.3 volt architecture. So it was decided that it would be safer and more stable to switch the 5 volt relay with a transistor. And in that case, we can also decouple the microcontroller circuit from the relay coil in order not to draw too much current from the microcontroller. This over here is the relay that switches the street lights on and off. I'm not going to touch it. I have isolated the live electricity coming into the relay. We can see the neutral at the moment and the live Well, both of these are actually live connections because the live is just simply interrupted. So both these wires, blue and red, are actually the live wire just being interrupted by the relay. And then on the terminal block down here, we can see the neutral coming in, and the neutral is being normaled through. This is the power incoming from the wall socket. And we also have then the live going out and being broken by the relay. Then we have the LDR sensor using a voltage divider to analog read the LDR reading on the microcontroller. And then the most important part is the ESP8266 node MCU. So right there, that's the microcontroller. And I will just keep it inside it. I can actually remove this module. So there it is. That's the ESP8266 sender module with the sender code loaded onto it at the moment. I'll just put that back. All right. Then we have the receiver module, and the receiver module is basically the same. It just does not have the day-night switch. So it's exactly the same. It has different code loaded onto the microcontroller, and it does not have the day-night switch since it's a client or receiver module. Thank you. I will now demonstrate the system. So at the moment the system is on. So in other words, the street lights are turned on because it's dark in the room. The system has been calibrated for this demonstration specifically, so in real world circumstances the night threshold will have to be changed to the value pointed out in the design report. So at the moment the street lights are on, and what we will do now is I will just simply use a light source. I'm going to use a torch to activate to deactivate the system through the LDR, through the day-night switch. So I will basically just introduce light to the LDR, and then we will see the system switch off, and two things will happen now. So if there's light applied to the LDR, then this module over here will switch its relay off, and this light will go off, and at the very same time it will send the ESP now signal and tell this one to also switch off. So let's have a look at that. Alright, so the system is on, system is off. So this is daylight conditions. So if we have sunlight, enough sunlight present, the street lights will be off. And then the moment that the sun goes down and that night threshold is reached, the system switches on again.